look at what makes up the stuff that's around us, the matter that's around us. It's made up of a mixture, a combination of elements, compounds, and mixtures. We're going to start off looking at elements. So when we slice and dice the matter around us, the smallest thing that we get that still retains properties of this world are called elements. So there's a series of elements, a number of elements, and Dmitry Mendeleev was one of the first to propose that there's a periodic repetition of properties of the elements when we arrange them in order of increasing mass. He originally did it in terms of 8 groups by the chemical formula of either the oxide or the hydride. And from this, that's our first chemical property, is the type of oxide, type of hydride that is formed. So in this table here, the columns are based on the type of hydride or oxide that are formed. And the other thing is that when he did this, he could see that there are some missing elements and predict relatively where these missing elements are going to be and what type of chemical properties they will have. But there was an issue with ordering the elements by mass, and we found out that the better way of ordering it is by atomic number. Atomic number is the nuclear charge, so the electric charge on the nucleus of the atom, or the number of protons in the nucleus of an atom. So atomic number is the best way to order our elements to get this periodic repetition of chemical properties. So our periodic table is going to be arranging elements in terms of increasing atomic number. We've expanded the table to have 18 columns instead of the original 8. And this expanded version gives us some additional information that is useful to us. So the periodic table is going to show the symbol of the element, possibly the name of the element, the atomic number of the element, the atomic mass of the element, and some tables can show other information also. So here's a table, good. So let's see, some metals, columns, okay. So we have 18 columns. We have 2 numbering systems for 18 columns, 3 if we look at what they use in Europe. But we don't want to look at Europe's. So the 2 numbering systems, the international system, UPAC system, is just number 1 through 18. So we're just counting 1, 2, 3, 4, 5, 6, 7, all the way up to 18. The American system uses A and B letters here in Roman numeral, and they start off 1A, 2A, then go to 3B, 4B, 5B, 6B, 7B. Now it's a little odd, is 8B, 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 so we have 3 columns for 8B. Then we go back to 1B, 2B, then 3A, 4A, 5A, 6A, 7A, 8A. In the American system, the A's and B's are separated by a broad category that we use. All the A column elements are what we call main group or representative elements. These are the elements that have the most dramatic changes in chemical properties. And the B group, that middle portion of the table that's lower, these are the transition elements. And the variability in these are lower. In fact, they're all metals. So in this table here, we have atomic number 1, hydrogen. It's kind of drifting off in space. It's normally stuck on top of column 1. But hydrogen is what's called a nonmetal. So all these yellowish elements are nonmetals. And officially up to the red line would be nonmetals also. Boron, silicon, arsenic, tellurium, astatine are nonmetals also. Everything below the red line, everything below the red line are metals, including the germanium, antimony, and polonium here. But all the green, which is all the elements touching the red line except for the diagonal red line, except for aluminum, are also called semimetals. So boron is a nonmetal, it's also a semimetal. Germanium is a metal, and it's also a semimetal. Okay, so our columns, what our columns are doing is we're grouping our elements into columns based on similar chemical properties. So if we look at one element, an element that was most likely to be similar in chemical properties is going to be one of the elements in the same column. Okay, physical states of our elements are mostly solid. Most of our elements are going to be solid at standard state, which is 25 degrees Celsius, 1 atmosphere pressure. So this is pretty much our standard living conditions. We're under roughly 1 atmosphere of pressure, and we usually like weather close to 25 degrees Celsius. We have a set of gases that are mostly on the upper right corner of the periodic table. Hydrogen also is a gas, which normally is on top of column 1. Nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton, xenon, radon are all gases. So this last column here are called the noble gases. So this whole column is gases, and we would kind of expect that 118 might be a gas also. We only have 2 elements that are liquid at room temperature, bromine and mercury, so a non-metal bromine and the metal mercury. And we have others that can melt close. Gallium will melt based on your hand temperature. Atomic number and atomic mass. This periodic table has neither one of those. So the 2 numbers that we usually show in our boxes of the periodic table. So the boxes, 1 box for each element. The boxes will have a 1, 2, or sometimes 3-letter symbol that represents the element. It might have the name written out completely for the element. And then there's usually 2 numbers present. The one that is consistently a whole number everywhere would be the atomic number. It doesn't matter whether it's top, bottom, or whatever. Each periodic table is different. And then the number that's usually a decimal number and occasionally a whole number in parentheses would be the atomic mass. So all the atoms of one element, such as hydrogen, are not identical. We have some variations where the mass of the element can change based on a neutral particle, the neutron. Our periodic table does not show isotopes. It can show does not show radioactive isotopes. When all the isotopes are radioactive, we tend to use we give the mass in as a whole number in parentheses instead of a decimal number, and that's because we're given the mass number, a whole number of the most stable isotope in parentheses. Okay. So we have special names for some of our columns. Okay, first the rows, horizontal rows, are called periods or series, and we have 7 of those, 1 through 7. And that number shows up left side of the periodic table, the period number. Our vertical columns are called groups or families. We have them numbered 1 through 18, or the AB numbering system. And we have a couple of special names. Group 1 are alkali metals. Alkali metals, that would be lithium, sodium, potassium, rubidium, cesium, francium. Hydrogen often sits on top of this column. Hydrogen is not a metal, so it's not one of the alkali metals. The alkali metals are extremely reactive. They'll react with water, they'll react with air, they can react explosively with water. Group 2 or 2A are called the alkaline earth metals. So this is right next to the alkaline metals. The alkaline earth metals, beryllium, magnesium, calcium, strontium, barium. These are reactive metals, but not nearly as reactive as the alkali metals. Over on the right, column 18 or 8A is the noble gases. They're noble because they do not react with other elements. And then there are gases because they're very stable in themselves and do not react and do not even stick to themselves. Column 17 or 7A are the halogens. These are very reactive nonmetals. We tend to use these chlorine for disinfecting drinking water or swimming pools. Bromine has been used for disinfecting swimming pools. Iodine has been used for disinfecting drinking water, and that's because they're very reactive. They'll react with almost anything, and in the process, when they react with proteins, they denature the proteins and they kill the bacteria that holds that proteins. Still working. Okay, that's those. We have several regions of the periodic table. So the 2 left columns and the 6 right columns. So the A group columns are either the representative elements or main group elements. And these elements are the ones that have the most reactive, most dramatic changes in their chemical properties. The B group elements are the transition elements or transition metals, since they're all metals. And then the 2 rows that are hanging down and bottom are the inner transition elements or inner transition metals, since they're all metals. And we give these 2 rows separate names also based on the element that precedes them or initiates that row. So the first row is lanthanides and the second row is actinides.